Hello everyone, in this second lesson of the two streams unit we're gonna tackle the temperature versus enthalpy diagram and the minimum temperature difference. The temperature versus enthalpy diagram is one of the principal tools we're gonna use in this subject, and is a diagram where the heat exchanger operating conditions are best understood. In this diagram, we represent temperature in absolute values in Celsius or Kelvin in the y-axis and the duty difference of enthalpy in kilowatts in the x-axis. Be aware that the y-axis refers to the second law of thermodynamics, while the x-axis refers to the first law. See how a stream works in this diagram. A hot stream starting at high temperature is getting cool and cool and cool till the final temperature, the target temperature, losing a concrete specific amount of heat. And more or less the same for a cold stream. Starting at a low supply temperature, it gets heat and goes hotter and hotter till the final target temperature. This is a convention. For a hot stream going right to left, it means that enthalpy gets to more negative values or reduce its value, while cold stream going left to right is gaining enthalpy or going to higher values of enthalpy. In this diagram, the slope is the reciprocal, the reverse of the product MCP, the flow rate times the heat capacity, with total units of kilowatts per Celsius. And if you remember the equation, this MCP is the relation between the duty over the changing temperature. Get to the intuitive concept of the thermal inertia, the MCP. It gives us the amount of heat that we must put or take it out to change a concrete amount of temperature, a concrete number of Celsius, and come from the combination of both things, the flow rate, if the flow rate is big, or the nature, the heat capacity, if the heat capacity is big. The product is what matters. For a start, we will consider MCP as a constant, and this makes the streams straight lines. Moreover, taking the sign of the slope as positive is just a convention. It's the same thing. We can have taken the slope as negative for both cold and hot stream and work in the same way. The last but important thing about this diagram is that the values of temperature are absolute, 100 Celsius or 600 Kelvin, but the values of the duty, the enthalpies, are relative. It depends on the origin. What is important for enthalpy is the difference between streams, not the absolute values. In other words, the y-intercept of a stream can be whatever, because enthalpy has not absolute value. Therefore, you can scroll horizontally the streams to either side if you don't change the size, the duty, or the height that you must respect. Not changing the form, not changing the level, but you can scroll it right or left. The minimum approach, the minimum difference of temperature, can occur at the hot or the cold end, depending on the relative slopes. You see here the minimum approach will appear at the left in the cold side of the heat exchanger. But it could have been at the other side. Then, how much heat can be recovered from hot stream to cold stream? Clearly, it depends on the minimum approach, the approach temperature. See these two diagrams. In the left, the temperature approach is short and the heat recovery is big. At the right, the cold stream has scrolled to the right. The approach temperature is wide and the heat recovery has become lesser. In general, the greater the minimum approach, the lower heat recovery, and the greater heating and cooling needs. Because you can see in this diagram, this is the heating, and this is the cooling. This is the cooling. That changes with the duty. From the heat exchanger design equation, we can see also that the greater the minimum approach, the smaller will be the heat transfer area. What we knew already. As the minimum approach in one side and the other side increases, the duty decreases and the area becomes smaller. The minimum approach will be a crucial parameter in every heat integration project. It must be chosen by the design at the start and come from a compromise between investment cost and energy savings. I say it is chosen at the start, but then it will be checked or changed.